All right, so we've gathered things for part A, which is going to be checking the pH of various household chemicals. I've got 6 containers. You could use different containers though. You could use a different style of cup, or you could scavenge plastic containers. So just get some kind of containers, ideally consistent to work here. So as you go through your procedure, we're going to put different chemicals into each of these. I've got a 1 cup measuring cup here, but you could use a different type of measuring cup, or just tablespoons if you needed to. So into the first measuring cup, into the first cup, I'm going to put a 1/4 cup of just straight up water. Okay. Into the second one, I'm going to put another 1/4 cup of water. And this time I'm going to add to it a teaspoon of baking soda. So get your measuring spoons out if you have them. If you don't, just use a consistent amount on like a teaspoon if you've got that around. So level it off so it's consistent, and that's going to go into my second container. All right, you're going to continue following the directions. For this, I would recommend anytime we add that solid that we're going to stir it up to help that dissolve. And then every time I use a knife like this or a spoon or whatever, make sure that you rinse it off with water. It may even be convenient just to keep a waste water nearby. Just make sure you don't use it for anything once that's been used as your wastewater. Okay, so you're going to follow the directions and fill each of these cups up. So I've got the first 4 cups filled up, and then the last 2 you get to choose what you want to do, and it says just to use a tablespoon, so I grabbed some apple juice. That's going to be my 5th thing, and you don't need quite as much, you can even just estimate. And then my 6th thing is going to be some glass cleaner. It doesn't have to be name brand, obviously, but about a tablespoon. And so I'm going to spray just a little bit of that into my cup. Okay, so now you have 6 solutions and you're ready to test the pH. So to test the pH, you want to use the picture of these reference numbers that has been provided in your lab. And we want to use a clean knife each time, okay, to not take our pH paper and contaminate the whole container here, but rather to dip your knife or your spoon into that solution and then spot a little bit on your paper here, okay? If I can zoom in down here. All right, we can see this was my water and my pH is, matching up pretty well there around 7, or we might say 7 to 8. Okay, I'm guessing that cup was a little dirty because that's a little bit high for pH of water. Once you've tested that first one, rinse your knife off. Dry it off, make sure it's nice and clean, and you go to the next one. This was, I think, some baking soda. So you would spot that, rinse, dry. Here's some vinegar, spot that, rinse, dry. And we want to be getting our pH estimates, whatever those numbers are, right away. So I'm going to match those colors up to see what I've got. All right, so once you've done that, you are finished with cups 5 and 6. But you want to hang on to cups 1 through 4 for the next part. All right, so moving on to the next piece, we're going to actually keep all of these containers, and I've measured the pH in all of them now. Now we're going to measure the pH not using our pH paper, but instead using an indicator. And so I've sent you a little baggie of purple red cabbage that's been dehydrated, and you're going to take that whole entire packet of red cabbage. I've got probably more here than you do, but you're going to dump that into, start with a cup of water, okay? And so you're going to add that to a cup of water, and you can dump the whole amount into a cup of water, okay? This is giving me a pretty dark purple solution. You could probably, it might smell a bit too, you could probably dilute this up to 2 cups maybe, but I'm just going to leave it as is, as a very rich purple color, okay? And so now what you want to do is test that this hasn't changed the pH of this solution, okay? So I'm going to rinse my cup off, or my knife off, and I've got a fresh little piece of pH paper here to measure the pH of my water. As you can see, I can still confirm that that pH, it's a bit in the shadow here, pH is still very similar to pH of 7 that my original water was. So even though this changes the color, it doesn't change the pH dramatically. And now you get the fun part. So now we're going to take a tablespoon, so tablespoon or a large consistent size spoon of this red cabbage indicator, and I'm going to add it to each of my solutions. And what you're going to find is that this red cabbage indicator changes colors depending on the pH of the solution that it's in. Oh, it's so cool. So it turns pink in acids. It's purplish in something neutral like water. And then I've got salt water here. And then I used apple juice. So that gives us an idea that apple juice is similar to the vinegar. And then this is some cleaning fluid, some Windex. And that's a really kind of turquoise kind of color. So that's going to be more basic even than my neutral solution over here with the water. All right, so you're going to do that and see what all your colors are. At this point, we're done with cups 5 and 6 once you've gotten those observations down. So I'm going to rinse them and clean them out and bring them back. So now we're moving on to part C. We're going to look at some neutralization reactions. So I need 3 clean cups here, and I'm going to change my numbers. Now we're talking about experiments. So we're going to talk about experiment 1 and 2 and 3. So experiments 1 and 2 and 3. I'll just get you going by showing you how that first one's going to work. So new clean container. We're going to clean off our tablespoon that we've been using. And in that first container, we want to put 2 tablespoons of this sodium bicarbonate. So that was our original 2, all right? So I'm going to put 2 tablespoons of that in here. In your data table, you want to make a note of the color on that. Take my tablespoon, clean it off. All right, and then instructions are to add 2 tablespoons of the acetic acid. So that's this pink stuff. And I'm going to watch what happens. That's one, and then we'll do a second one. And you'll notice that we've got some definite color changes, some definite fizzing, and so you're going to be writing down observations about that fizzing. This is a neutralization reaction, and I love the colors because the colors are showing me that I took a base, which was blue, and I took an acid, which was pink, and I ended up neutralizing them. So I have a pH that's somewhere between acidic and basic. So that's the idea of a neutralization reaction, is to give us a more neutral or closer to 7, closer to the middle pH. So you'll continue following the directions to do experiment 2 and experiment 3. In experiment 3, you're going to have to get some fresh vinegar, most likely, unless you happen to have some vinegar left in container 3. And then at this point, you're going to dump out, rinse out all of your containers to get ready for the final experiments of the day. All right, final part. We're looking on part D now, and I've assembled all of my things, including some baking soda and some vinegar. So we're going to be continuing our neutralization reactions of base plus acid as we do this. So I've got my 2 plastic bottles. Okay, this is kind of an ad for Target generic brand stuff, I guess. The first thing that you're going to do is you're going to get your tablespoon or your consistent tablespoon-ish measuring thing, and you're going to put 2 tablespoons of vinegar into each of these bottles. Pour carefully. You could probably use a funnel if you had one around. I'm going to pour those 2 tablespoons into each bottle. So now that I've got 2 tablespoons of vinegar in each of these, this is one of my reactants. My other reactant is my baking soda or my sodium bicarbonate. And before I use that, I want to add some indicator so I can see what's happening real time in here. So I'm going to clean my tablespoon off, and then I'm going to put a tablespoon of indicator into each of these. Now I'm adding it into acid, so I'm seeing that pink color show up right away, right? Which is what I expect. It should be pink when I put that indicator in here. All right. You can see where it's neutral on the counter, it's more purple. but here I've got that pink solution. So I've got that ready to go, and now into each of my balloons, so you should have 2 balloons that you received in your lab kit. We're going to put different quantities of the other reactant. The other reactant is our sodium bicarbonate, and so I've got an 1/8 teaspoon here. If you don't have these teaspoons around, just estimate 1/8 and a whole quantity. So this is 1/8 teaspoon, and I'm going to just very carefully do my best to pour it into the balloon. Okay, and you can kind of shake it down into the balloon, and then I'm going to take that 1/8 teaspoon and very carefully I'm going to stretch this balloon out, and I want to cover this bottle top really well, but ideally that baking soda has remained down here in the balloon. Okay, so I'm going to do the same thing now. I've got my 1 balloon ready. I'm going to get the other one ready with a whole entire teaspoon, so 8 times as much baking soda. Once I've got both of those balloons securely on the top of the bottles, what you're going to do, and I'm just going to do 1 here to start with, but you want to do both of these simultaneously and be ready to observe. It's going to happen fast. You can always redo this. It's a really fun little experiment, so you can redo it more than once. But I'm going to lift that balloon up and kind of shake that baking soda down into the container. And as that is happening, you should see some bubbles and you should see some gas being captured. All right, so you're going to do both of those at the same time so you can compare and contrast. And then you will design your own experiment to do a little bit more of that. So I hope that gives you an idea what some of this is going to look like, and I hope you have fun blowing balloons up.